Okay, so this is the introductory video to the circles unit, which we'll be starting now. So first we're going to look at some key vocabulary that have to do with circles. So the definition of a circle is a set of all points that are equidistant from a point, which we'll call the center, right? So if that's the center of the circle, then all these points here are equal distance. Point 1, point 2, point 3, they're all equal distant from point C, all right? So that's the definition of a circle, all the points that are equal distance from C. An interior point is a point that is inside of the circle. So again, our center point is an interior point, but any point that's inside is also called an interior point. All right? An exterior point is a point that is on the outside of the circle. Again, there's my center, and there's my point on the outside. That's an exterior point. Okay, so a chord. A chord is a line segment, right? And remember that line segments have endpoints. So a line segment whose endpoints are on the circle is called a chord. So if this is point A and this is point B, then AB is a chord. Okay? A diameter is a special chord, right? This is a special chord because its endpoints, right? Its endpoints are on the circle. So AB is still has endpoints on the circle, but C is the center. So that makes AB is a diameter because it covers and goes through the center. It goes a chord that passes through the center of a circle is a diameter. And last, a radius, right? A radius is a line segment whose endpoints are the center of the circle and a point on the circle. So if that's point C, my center, and that's point A, then we can say CA is a radius. And of course there's multiple radiuses, right? If we call that B, then CB is also a radius of circle C. Okay? So this is a radius, and this is a radius, and they are equidistant, right? The radius is the distance from the center to the circle. The length of the radius is the distance from C to B. It's also the distance from C to A. All right? The diameter is equal to 2 times the radius. The radius is equal to the diameter divided by 2. Right? So knowing these formulas will be important later on. Right? Diameters are 2 radiuses. A radius is half the diameter. Okay, so a few other types of segments and lines. A secant is a line that intersects a segment at 2 points. So if this line, notice it continues infinitely throughout, right? Intersects the circle at point A and point B, then it is a secant. Secant is a line, right? So I would call this a line AB, right? Line AB is a secant. As opposed to a tangent, where a tangent is a line that intersects a circle in exactly one point, right? So a tangent intersects the circle in one point, okay? So again, we'll label this A, and this B, and we'll say line AB is a tangent. Line AB is a tangent because it crosses at exactly one point. Point of tangency. The point of tangency is just the point where a tangent line intersects the circle. So there's point P, and we'll say P is a point of tangency. And there's all kinds of interesting properties that we'll be talking about when we get to tangencies and tangents and secants. But for now, just know that a point of tangency is the point where a tangent line intersects the circle. Okay, so a sector. A sector is a slice of a circle, right? Sectors are always measured from the center of the circle C, right? So AB, so sector AB would include all the space from the center, from CA to CD. Okay, so it's a slice of the circle, and remember, sectors always work on the angle C. Concentric circles. A concentric circle are circles with the same center. So if I have center C here and circle C, imagine that that's there, right? And this blue center to this blue circle, right? The red circle and the blue circle have the same center, so they are concentric. Concentric. All right, so an arc. An arc is an edge part of the circle, right? So we're only talking about the edge of this circle. So if I call this A and this point B, then I would have arc AB. All right? So arcs are the edge parts of circles. There are two types of arcs, right, that we'll talk about. One is a major arc. A major arc is an arc that measures more than 180 degrees. And this needs to have 3 letters, right? So if I have point A, point B, and point C, then I would call this, the red line would be arc A, B, C. So I'm telling you to go from A to B to C, and that would be my arc. If I start here at A, and I go around this way, then that would be, the blue arc would be arc A, C, B. And those are 2 different arcs, right? But you follow the direction it tells you to go in. Go from A to B through C. Go from A to C, but go through B first. Okay, major arcs, more than 180 degrees, which means they're more than half the circle. A minor arc is one that measures less than 180 degrees, which means it's less than half a circle. So if this is A and this is B, this would be arc AB. You could also call it arc BA. That would be the same thing. But if I have this point C, then this would be CB. Okay, so last thing here is what we call a semicircle. Semicircle is when the endpoints of an arc are the endpoints of the diameter. A semicircle really is half a circle, right? So there's my diameter going through the center C. Here's A, here's B. And you really have to call a semicircle is really, you treat it like a major arc, but it has a special name. Just like a major arc, it needs 3 letters, right? 3 letters. So I would call the red, right, A, D, B is a semicircle. However, if I put this point down here, P, and I drew APB, arc APB is also a semicircle. But they're different semicircles, right? Start at A, go to B, start at A and go to B, but this one goes through D, and this one goes through P. So those are different semicircles. Let's say I have this point over here, X. Well, arc ADB is equal to, it's congruent to AXB. They are the same thing. ADB and AXB are the same semicircle. They're the same. But ADB and APB are different semicircles because they're going through different parts of the circle. Okay, so a couple last things here. Central angle is an angle whose vertex is the center of the circle. So a central angle has a vertex at the center Alright, so we can talk about angle ACB, right? If I say angle ACB is X, then arc AB is also X. So the central angle we'll get to in a little bit, but a central angle is just an angle that has a center with a vertex at the center, right? Central angles are angles that have a vertex at the center. The center is the vertex, all right? Inscribed polygons are when each vertex of the polygon lies on the circle, okay? So what would that look like? An inscribed polygon means that the polygon is on the inside, right? Each of these vertexes of the polygon is a point on the circle. Whereas an inscribed circle means that the circle's on the inside. In circumscribed polygon, right, when something is inscribed, it's inside. When it's circumscribed, it's on the outside. So an inscribed circle means it's on the inside. A circumscribed polygon is the same thing. it's on the outside. So it's tangent at each of these 4 points. Each side must be tangent to be circumscribed, and each vertex must be on the circle to be inscribed. Okay, so know the difference between what we're talking about when we say inscribed polygon. This is an inscribed circle. This is a circumscribed circle and a circumscribed polygon. So a little bit of practice about determining if they're inscribed or circumscribed based on those 2 definitions. You can do that on your own. What I want to talk about here on the last page, we're just talking about the relationship, right? We talked about major arcs, right? Major arcs have to have 3 letters. So ACB is a major arc. ACB is a major arc. A minor arc uses 2 letters. Right? So uses 2 letters less than 180 degrees. This uses 3 letters and it's greater than 180 degrees. Alright. Now a central angle, right? We'll call it angle APB. Okay. The measure of the minor arc equals the measure of the central angle. These 2 things are the same. If I say this is 50 degrees, then this arc has to also be 50 degrees. The measure of the major arc is 360 minus the minor arc. So in this case, we'd have 360 minus 50, 310 degrees. So this would have to be 310 degrees from this point around to this point. So a little bit of practice here, determining whether these things are major arcs, minor arcs, semicircles. Remember, semicircle has to be exactly halfway. All right? And then just a couple formulas that I want you to make sure you know. Circumference of a circle equals 2 pi r, or also known as circumference equals pi times the diameter. The area of a circle is equal to pi r squared Okay, so we'll be using those when we find arc length. Now the arc is a part of a circle. It's a fractional part of a circle. So if we have arc AB, you divide it by 360, and you'll have a fraction of the circle. You're going to multiply that fraction times the circumference, which is 2 pi r, and you'll have the arc length. Area of a sector is the measure of the arc divided by 360 multiplied by the total area. Because the area of a sector and an arc length, right? A sector and an arc are just parts of the circle. They're fractions of the circle. So if I go halfway around the circle, I've gone 180 degrees. 180 over 360 is 1/2. I have half the circle, so I should have half the area. If I have an arc length, a semicircle, then I have half of the circumference. So we'll be practicing that and working on that in class next time. But focus on this vocabulary, make sure you understand it, and do the extra problems that were left over, and I will see you in class next time.